was going to kind of skim over it. But now we can take a little bit more time and go into a little bit more detail in certain areas. Please, if I lose you or you have questions you want to ask, or if something's not particularly clear, feel free to stop me and ask. And we'll feel our way along as we go along. All right, so reason I chose this topic is we've got quite an exciting summer astrophotography competition, which I think ends in Jan or February if I'm correct. And we're trying to line up some nice prizes, and if the prizes that were mentioned come through, some of them should be very nice indeed. And also, I think quite a lot of people kind of toy with the idea of doing this. And this type of astrophotography, some of the areas are more technical, some of the areas are less technical, and some of the areas are quite easy to get into. As with everything else, to get a photo at night is easy. To get a good photo at night requires some time and effort and dedication and homework and a minimum of equipment and some trial and error. And like all skills, the more you practice, the better you get at it. And so you can't just walk out, point the cell phone at the sky, snap a photo and expect to have an award-winning photo. It just doesn't work that way, unfortunately. But maybe what we go through tonight will make it easier. Now, I've tried pretty much all of this stuff. I won't profess to be an expert because I haven't really put in a huge amount of time and dedication to become an expert, but I have tried pretty much all of this stuff. So while I'm not a huge expert on it, I think I've been through it and I've bumped my nose, and hopefully I can give you some helpful tips and some guidelines. All right, so solar system astrophotography, by that we include photographing the moon, the sun, planets, meteors, starscapes with a terrestrial foreground, and obviously if you can capture a comet with a terrestrial foreground, that would fall into that category. And we'll have and really this could be a long talk because every one of these areas is quite a large area if you really want to get into it in depth. So we're really just going to look at the very basics involved. And let me just say that all the photos you see... Oh, we've got an echo somewhere.
Can you guys just mute your mics?
Please. All right. All the photos that you're going to see tonight I've pinched off the internet, basically. So it's public domain photos. And they're all pretty much off the internet. All right, so let's start with equipment, and there's some guidelines on equipment, and they apply pretty much across the board, and some of these guidelines really can be the difference between success and disappointment. And right, let's have a look. So the first and biggest rule is use a firm support for your camera. Be it a camera, be it a cell phone, and I know the cell phones these days are wonderful. They've got these intelligent cameras and you can do wonderful stuff with them, but please, if you're going to do night sky photography, mount the thing firmly. All right. Now, I walk past these shops in the mall and they sell these little ring lights on tripods for I'm not quite sure what they call themselves, the influencers we take TikTok. Selfies for TikTok and stuff, and they're mounted on these tripods. Those are not tripods, those are toys. So go to a photography shop and buy a proper tripod. And tripods, we have the traditional, it's called a triangle. So you have three factors when you buy a tripod. You can have cheap, you can have rigid, you can have light. You can choose any two of those. You will not get all three. So I can buy a heavy, rigid tripod, and it'll be quite cheap. I can buy a rigid, light tripod, and it'll be very expensive, etc. So, but please, tripod with a head on it and a bracket for your cell phone, or mount your camera on it, and that is really where you start from. You're wasting your time if you're not doing that. So very, very key and very basic. Then don't set the camera or the cell phone up on the stand and punch the button, because it will vibrate and you will ruin the photo. So buy a cheap cable release, or buy an intervalometer if you're more serious about this, or use, if you've got the self timer on your cell phone or your camera, use the 2-second self timer to trigger the shutter. You touch the shutter and it gives 2 seconds for the vibrations to die down, and then it triggers the exposure. And you're not going to get shake, rattle and roll in your photograph. Highly recommended, if you do get a little bit more serious about this, is use an intervalometer. A lot of the modern cameras have a built-in intervalometer. And by an intervalometer, I mean, you go look down in your menu and you will find a function that allows you to say, I want to take 3-second exposures, and I want to pause for 1 second between exposures, and I want to take 100 exposures. And you set all of that up, and when you push the button, it will do just that. It will shoot a 3-second exposure, wait a second, shoot another, shoot another, shoot another, until your 100 exposures are done. So if you've got it built into the camera, lovely. If you haven't got it built into the camera, you go and look on Amazon, not Amazon South Africa, Amazon.com, and they sell intervalometers there. They are not terribly expensive, and it doubles as a cable release. You can use it as a cable release as well. So it's a very, very nice accessory to have. And as I say, they're not horribly expensive, and it'll last you a long, long time. Then, very important, when we shoot at night with all of these things that we're going to do, we shoot in full manual mode. So we set the shutter speed manually, we set the f-stop manually, we set the ISO manually, and we focus manually. The autofocus on your camera is not very good. It might work on the moon, but it doesn't work on much else. So we manually focus, and I'll give you some tips on how to achieve manual focus. That's one of the more difficult areas that you're going to have to wrestle with. And then use an appropriate ISO setting, as low as you can get it to reduce noise, but as high as it needs to be to capture what you want to capture. Generally make a mistake of capturing a little bit on the dark side, because you can always recover that in post-processing. If you're shooting the moon and you are shooting too bright, or you're shooting a planet and you're shooting too bright, once you've blown out your whites, you've blown out your whites on a digital camera. There is no way that you can ever recover them again. So rather shoot what looks to be a little bit on the dark side, and then you've got lots of headspace to post-process and get these things done. Again, very important, shoot in RAW if possible. Or shoot in RAW plus JPEG. The JPEG will give you an idea of what you've got. Once you get into serious post-processing, RAW gives you far, far, far more headspace than JPEG does. If you get into these stacking programs and stuff, most of them want TIFF files, and writing TIFFs from a RAW exposure will give you much, much better results than the JPEG. And the JPEG also has a lot of artifacts in it, because it's a compression mode of saving things. So please resist the temptation to use JPEGs. Shoot RAW and then put it into TIFF, 16-bit TIFF if you can, 8-bit TIFF if you can't. Any questions so far?
You need a big fat memory card for all those RAW files.
Yeah, memory is cheap these days.
Yeah.
It's not very expensive at all, and depends on the camera. So yeah. But you can do things with the RAW file that you just can't with the JPEG. I don't want to go into detail. It's just so much. It gives you so many more options at the end of the day. All right. Then very important is the lens. So we're assuming at this point that we're doing a landscape or something. We're not talking telescopes at this point. We're going to put a lens on the camera. If you've got a cell phone, you've got a lens in the cell phone. You live with what you've got. If you've got a DSLR or a mirrorless, you can change lenses on it. And usually a fixed focal length or prime lens usually gives better results than a zoom lens. There are exceptions to that. But you've got less glass in a prime lens. They tend to be sharper, especially in the corners. And they generally just give better results. There are some exceptions. The Nikon 12 to 24 f2.8 is a legendary lens, and that's one of the very few zoom lenses. I don't own one. I don't shoot Nikon, but that's one of the few zoom lenses that I hear is really, really good. But they are few and far between. So generally a prime lens is better or preferable. And then be careful. Some otherwise very, very good lenses suffer from chromatic aberration and just don't give good results for astro. So what's chromatic aberration? That's when the stars in the corner look like little comets. They become streaks. And so you don't get nice, sharp, round stars in the corners. They look like streaks. And some otherwise very good lenses suffer from that. We'll talk about some decent lenses when we get a little further and deeper into this, right? And then usually we want as much light as we can because it's nighttime, but usually stopping down one stop from maximum will give a sharper and better result. So if you're starting off with an f2.8 lens, stop it down to f4. You're going to have to double your exposure time, but you will get a better result. If you've got an f2 lens, lovely, but stop it to f2.8. If you've got an f5.6 lens and you have to stop it to f8, you might want to consider getting a faster lens because in that region you are really, really going to battle. All right. Then, most cameras come with a long exposure noise reduction. So what that does is I'm taking a 30-second photograph, so it takes 30 seconds of the subject, and then it closes the shutter and it takes 30 seconds of darkness, blackness, nothing. And what it's doing is shooting the noise pattern of the sensor, and then it subtracts that noise pattern from the sensor from the photograph to give you less noise in the final photograph. Now the problem with that is that you're losing half your time, half your exposure time. So I shoot for 30 seconds, I lose 30 seconds. I shoot for 30 seconds, I lose 30 seconds. And there are better ways of overcoming that, and we'll talk about that a little further through the talk. We take what we call our dark exposures, and the software that you will use to sort things out afterwards will use those darks to do that subtraction for you afterwards in the processing software. So switch off your long exposure noise reduction. Okay, very important, do not use any filters. Do not use a UV filter, do not use a skylight filter, do not use any filters. They cause weird effects and they will wreck your photos. So very, very important. Toss the filter. Never, ever, ever put a filter on for nighttime photography. And then most lenses come with a lens hood, and a lot of people never use the lens hood. The lens hood is wonderful. Put it on, use it. It will exclude stray light from coming into the lens, and you will get much, much better results. All right, do we have any questions at this stage?
Not yet.
Everybody with me? Wonderful. Okay. So now let's look at the next area, and this is probably where you're going to battle the most, and it's really tough. How do I get sharp focus? Because I'm focusing on a dark night sky with some little pinpoints of stars, and those stars are very dim, and you can't really see them in the viewfinder.
Viewfinder is this big.
And it really is a challenge. It's really a challenge, and you go out and practice this. A lot of lenses have an infinity setting. Don't trust it. It's an approximate setting. It's fine for landscape photography. It's no good for astrophotography. So there's a couple of hacks that you can use. The least preferable is focus on something on the horizon in daytime, which will give you reasonably close to infinity. And if you get that sharp at maximum f-stop and then stop down one stop, you should kind of be in the money. Okay? Preferable is to set the camera to manual and use live view. Unless you've got a very old camera, most of the modern cameras have live view. And when you use manual exposure, a lot of the cameras have got a function where your live view will actually pop up 10 times magnification for you. And that is absolute gold. So set your camera to manual, use live view, push whatever button triggers that, and magnify the live view 10 times. And a lot of cameras, I shoot Fujifilm, and in Fujifilm, if I switch it to manual focusing, it gives me that function. I can set it up in the menus and it will give me that function where if I push the little wheel on the back in, it will pop up the view to 10 times. And then also with a mirrorless camera, go in and try and choose a display mode that will actually lighten the view and show you, put in more light. That's one of the advantages of mirrorless, is that you can actually set it to artificially boost the light that you're seeing, where with the DSLR you don't really have it. With the DSLR you've got a nice clear view through the lens, so it's a bit of a balance, okay? Then you choose a fairly bright star and you go backwards and forwards until you get that star as small as possible. You know you're starting to win when, as that star gets small, you see smaller stars suddenly pop into view. And then you're on the money, okay? Then you're good. So as your bright star gets smaller and smaller and smaller, it will reach a point where you'll see some dimmer stars. I'm talking dark sky here, not Johannesburg. The dimmer stars will all pop into view, and at that point you're pretty good, okay? Third option, and this works with long focus lenses or a telescope, use a button-off mask. If you don't know what that is, just go and do a quick Google on it. They are cheap, you can buy them, they're not expensive. They don't work well with short focus lenses. I've played with them, I've had custom button-off masks made that are supposed to work well with short focus lenses. They don't. There is a place in the USA that will sell you a button-off mask that allegedly works well with short focus lenses. It is hideously expensive. It's north of $100, and then you still have to pay to get it into the country. So they don't work very well. From 200, 300 millimeters up, button-off mask works just fine. And that gives you extremely good focus because it puts a little cross. It blurs the star into a little cross, and then there's a line that goes across the cross. And if I'd known this was going to be a longer talk, I would have put a slide up to show that. And you get that cross line to cut the middle of the cross, and you are focused, and it's very accurate. Once you have good focus, take a piece of masking tape or gaffer tape and tape the focus ring in that position so that you don't bump it or move it. So once you know you've got good focus, put a piece of tape on the focus ring and make sure the thing does not move. Okay, ask me. Been there, done that. I thought, yeah, no, it's fine. Yeah, it wasn't. So I wasted an evening. Okay, everybody happy with that? And this is something you need to get out and practice. It can be very frustrating, but as you practice over and over and over, you'll get to see and find out, and you'll get something that will work for you. And then the other strategy they recommend is once you think you've got good focus, take a photograph, magnify it 10 times and have a look at it. Move the focus ever so slightly, take another photograph, magnify it 10 times. Is it better? Yes, keep going. Is it worse? No, go back. So that's a little tedious, but that is another strategy you could use, trial and error. Shoot a photograph, put it on your view on your screen of your camera, blow it up big and see. But it's quite difficult to get right. So this is something you're going to have to work on.
John, I have a quick question here.
Sure.
Once you've found that perfect focus, will it always and forever be the same, or does it change over time? If you always use the same equipment, that is. Like, can I shoot tonight and again in 2 months' time, and I've taped it, will it still be the same?
With a short focus lens, probably yes. So if I'm using a wide angle lens, the answer is probably yes.
Okay.
With a telescope, definitely not, because a telescope expands and contracts with temperature. And if you're using a wide field telescope, I use for deep sky a 420 millimeter scope. And I find once I've got focus, I'm fine for most of the night. The temperatures here on the reef really don't change that much during the night. But if there's a big temperature change, then we have to go and recheck focus. But with shorter focus lenses, that should not be an issue. And then you get some lenses, very wide angle lenses, that literally, if you stop them, if you get it close to infinity and you stop it down a stop, there's a thing called hyperfocal distance. You can try that. For Astro, I'm hesitant to tell you to use hyperfocal distance. You will not get the best results. Okay? Again, let's talk about it now while we're talking focus. Some lenses, I'm just trying to think of the terminology, don't have a flat field of view onto your sensor. So they have a curved focal plane. They don't have a flat focal plane. And a lot of telescopes suffer from that. With telescopes, we buy field flatness to flatten that out. So what you might find is that you get a pin sharp in the middle and the stars on the edges are blurred. But when you focus on the edges, your edge stars go pin sharp and your middle goes blurred. So then what you generally do if you're forced to use a lens like that is focus on stars midway, okay, get those sharp, and then stop down 1 or 2 stops. And that should bring you into sharp focus right across the field.
Okay.
But again, you might want to try another lens if you've got a lens with a curved field on it. Yeah. So, yeah. All right. Happiness. All right. All right, so let's start with some targets. The first obvious and probably the easiest target is the moon. It's big, it's bright, it's overhead. It's illuminated by the sun. So the surface brightness on the moon is pretty much the same as the surface brightness on Earth during the daytime. So you don't need high ISO settings. You don't need long exposures. So we always used to shoot 16th of a second at f16 at ISO 100. The sunny 16 rule back in the days of film. I'm showing my age now. Most of these digital cameras start at ISO 200, so put your camera to ISO 200. Shoot at ISO 200. Focus at full aperture, use live view, do exactly what we did, magnify it, okay? Get it looking sharp. One of the problems with the moon is that we've got atmospherics. And if you look at it with a telescope, you will see it'll be hazy. It almost looks like you're looking through water. And it's a problem, and we'll talk about that now. So, and again, please, this applies to the planets as well. Don't think you'll get good moon photographs, sharp full moon photographs from the things just above the horizon. You won't. You're shooting through too much air. If you're doing a nice red moon rising above the horizon, wonderful. It works beautifully. But if you want moon photos showing reasonable sharpness on the craters and the seas and all of that, get it up overhead. Okay. And then again, full moon, not a lot of contrast on the moon. The photo that we just looked at there, that's been jippoed quite a lot to get the contrast there. And if you look at the top right-hand corner, you will see there's a little bit of terminator there that's bringing some contrast on those craters on the top right corner. Full moon, there's very little contrast. So generally, you don't want to shoot a full moon. How much bright and dark is very subjective, and that's up to you to choose, and that's your artistic license. You decide what you like there. Okay, so focus at full aperture. Your autofocus will get you roughly in focus, and then switch it to manual focus. Do the live view thing. Go backwards and forwards. Try and get it as focused as you possibly can. And then stop down. Try a 200th of a second at f11 as a starting point. And at f11, you should have that thing in focus, because you've gone from f2.8 or f4 or wherever you were. You've gone right down to f11, and you should have that fairly sharp. Just be careful with some of these mirrorless cameras. At f11, your photo starts going a little bit unsharp because diffraction kicks in with the small sensors. So you might want to try a 400th of a second at f8. Might give you better results. That's a starting point. And then try a little darker, try a little bit lighter. Generally take the photo to look a little bit on the dark side, and you can always boost it in post-processing. And you're shooting raw, so you've got lots of headspace to boost that in post-processing. All right, so always shoot a little bit on the dark side, what looks to be about half a stop or a little more underexposed, and then push it a little bit in post-processing will generally give you your best results. And with a lot of these Lucky imaging programs, the darker images actually work better in the Lucky imaging programs, which we're going to talk about. All right. You can get a decent result from a single frame, but stacking can give you a much better result, because stacking actually averages out a number of photographs that you take. All right, so it's called Lucky imaging because you take a huge number of photos, or a reasonable number of photos, and we go into software, and that software actually stacks all the photos together, and then it averages them all out, and then it's got special sharpening algorithms that you can go in and sharpen the image with. We'll talk a little bit more about it when we get to the planets, because to get a decent planetary photograph, that's what we've got to do. Single exposure on a planet, meh, doesn't work too good. All right, so take a number of frames in rapid succession. An intervalometer makes this easy. Shoot in RAW and then convert all these shots to TIFF files. With planetary, you generally shoot a video if you can. We'll talk about that on the moon. If you can take 50 shots in succession or 100 shots in succession with an intervalometer, and here I'm assuming that you've got a tracking mount or you're adjusting as you go along to keep the moon more or less in the center. 50 to 100 exposures will work very well in stacking software and should give you quite a decent result. You don't need thousands of photographs if you've got good focus. And again, with all of these, the moon, the planets, we are at the mercy of atmospheric conditions. So you want to try and choose the moon up overhead, and you want to choose nice still air conditions. Look at the jet stream forecasts, and if the jet stream is down, good night to go and shoot the moon or planets. If the jet stream is active, make a cup of coffee, go watch TV. Yeah. And we do have jet stream up above South Africa, so yeah. So, but you look on the internet, you've got these jet stream forecasts. Choose a night when the jet stream's low, and you'll find suddenly your sky's much clearer, there's much less movement and shimmering up there, and you'll get better photos. Okay. Once you've got your 50 or 100 files, shoot it in RAW. And in most software, Photoshop will do this, and Photoshop costs quite a lot of money, so not everybody can afford Photoshop. You can download free software called GIMP, G-I-M-P, that does probably 90% of what Photoshop does, and it's free. And so, and a lot of these things, like Canon, do a very nice RAW converter. I think Nikon does. You used to have to pay for Nikon's one. Canon's always been free. If you shoot Fujifilm, Phase 1, Capture One, you can download a free Capture One to use with Fujifilm. And they work very well. And what you do is you get one photograph nice, and then you tell it, take the whole rest of that batch of photographs and apply the same corrections to them. And it'll apply that same correction to all your 50 or 100 or whatever photographs. And then you write them into TIFFs. 16-bit if you can, 16-bit TIFF files. TIFF is a lossless format, so there's no compression artifacting with it. It's your best result, okay? Then there's free software that you can use. So take that process the stacked file using, there's a program called Registax. And for Lunar, Registax is fine, it's free, you can go download it. And Registax will stack your files for you, and they've got a very nice thing called wavelet sharpening. and you're going to have to play a little bit with that, but it's almost in layers. So you start with the coarse details and get them as sharp as you can, and then you get to the finer details and the finer details, and you slice down in slices, and it takes quite a lot of playing and fiddling with it, but you can get some really good results out of it. It's really nice software, and it's very good to use, and it's free. It's called Registax. All right, for lunar, that's fine. For planetary, we're going to look at a slightly different strategy. All right, and if you go through all of that, hopefully you should get a pretty nice lunar photograph. If you're going for the competition, it would have to be a staggeringly good moon-only photograph. If you look last year, or the 2025 winter competition, somebody did a very nice photograph where they had the moon and then they captured the ISS going across the face of the moon, which is really, really nice. Now, something like that would be extremely nice for this particular competition, but again, that takes quite a lot of planning, so it was actually a very nice photograph. So try and do something creative or different or whatever. All right, but any questions about shooting the moon? I say probably your easiest target. All right, the sun.
John, sorry, John.
Yes.
If your camera can shoot in TIFF, I don't know if that's possible. Then I suppose would it make sense just to shoot in TIFF, and you don't have to convert from RAW?
No, always shoot RAW plus something. You may need the headspace in RAW. So when you shoot JPEG, it applies an algorithm to it, and that's it. That's what you've got. So try and make a mistake and set nighttime on your camera, and then go and shoot photos in daytime, and then try and convert those photos back to look normal, because they will come out completely, color balance will be totally out, and you're cooked. You can't bring them back. If you shoot in RAW, it doesn't matter what color balance you set on JPEG, it doesn't matter, because you have the underlying capture file, and you can go in afterwards and you can put any color balance you want on it. Plus, if you're working towards the dark side or you're working towards the light side, where you've almost blown the photograph, so the JPEG, the photograph, the highlights will be blown. That's it, you're cooked, you're done. With RAW, you sometimes have enough headspace to go back in and recover those highlights. So always shoot RAW plus something else, plus whatever you want to shoot. And on most cameras it's JPEG, but always take a RAW exposure, because if you screwed up the JPEG, the RAW will often save your bacon. Good question.
Yeah, but what my question is, if your camera can shoot in RAW and TIFF, I'm not talking about JPEG. I know that's highly compressed.
No, if you can shoot RAW plus TIFF and you've nailed your TIFFs, that's fine. Go use the TIFFs, no problem. Yeah.
But you might still need, even though you've used shot in TIFF as well, you might still have to refer back to the RAW.
You might, and you might still want to adjust that TIFF a little bit, and for exposure or sharpness or whatever, and RAW always gives you more headspace. RAW always gives you more room to maneuver. All right. I'm not going to talk a great deal about the sun. There are people who specialize in solar photography, and if you don't know what you're doing, please don't go and mess with the sun. All right, so you better be extremely sure that you know what you're doing before you go and mess with the sun. So it requires proper solar filters. You can't use an old X-ray or an overexposed negative or a piece of tin foil or whatever. You need proper solar filters, which you can buy from the astronomy shops for your telescope or your lens, okay? And they are very expensive, but you have to go and buy a proper filter, or you buy the solar film, and if you make something to put that film onto your lens, make sure it can't drop off halfway through, because you will burn a hole right through your sensor. Okay. Or you get special solar hydrogen alpha telescopes. Mead used to make them. Coronado, yeah. Very nice little telescopes. Again, not cheap, and I don't know if they're still making them, but those are specifically made for viewing the sun. They have all the proper filters and stuff inside. Then there are things like Herschel wedges, etc., etc. If you are not expert with those things, just please, please, please. One slip, you could either blind yourself or destroy your camera. So make absolutely sure you know what you're doing. And really the sun, what you're photographing sunspots. So that's really, with the hydrogen alpha telescopes, you can photograph solar flares, which you can't just with the normal filters that you put on your telescope or your camera lens. This does not apply to sunrise or sunset shots. So if you've got that big red sun coming up over the sea at sunrise or setting over the horizon at sunset, that's perfect. You can shoot that. That's no problem. I'm talking about the sun, bright sun, reasonably high overhead. All right. So that's all I'm going to say about the sun. Just be very careful. All right, now the planets. So this is a Hubble Space Telescope photograph. So from here, we're not going to get that good. We aspire to it, but we're not going to get there. And that's quite frustrating for me about planetary photography, because
Well, some ASA members have gotten close.
there are some very good people who shoot extremely good planetary photographs who are ASA members, but before we go into the thing, let's talk about that. The guys who do this very well, probably the most famous guy is a guy called Damien Peach. He's in the UK. He does all his planetary photography in the Bahamas. Why does he go to the Bahamas? Not because there's white beaches and it's nice and warm. I suppose that too. And the drinks are nice. There's no jet stream. And you've got lots and lots of clear nights. Because planetary is a gamble. You need a clear night and you need good viewing. And if you don't have those two things, and the planets need to be up overhead, so we have a big advantage in the southern hemisphere. The northern hemisphere, generally the planets are lower to the horizon. So we have a big advantage here because Jupiter's coming up, and in the next couple of months it's going to come right up overhead. Very good conditions for photographing it. So we're lucky. So Bahamas for a reason. They also shoot these huge 14-inch Schmidt-Cassegrain telescopes with a 2 times or 3 times or 5 times Barlow, and they shoot planetary cameras, and I'll talk about that just now. These have been specifically forbidden in the competition for a very good reason. It takes the big dogs out of the competition and makes it fairer for everybody else. Because when the guy's got a 14-inch Cassegrain and a high-speed planetary camera, you ain't got no chance with your cell phone. You really don't. You're fighting a cannon with a pop gun. Yeah, and they're the guys who get not as good results as that, but very good results. And so it's a very specialized area of astrophotography. Not to say that you can't get nice results with lesser equipment, but you do need some equipment for this. So Jupiter's the easiest to photograph. It's relatively big, it's nice and bright. It'll come up nicely overhead in the next couple of months. If you get up in the early morning, you can start shooting it from pretty much now. I think it's already quite high up in the early morning. Saturn's very small, and you need a lot of magnification. It's a lot more difficult target. Mars is just difficult at the best of times. It's dull, it's red. You will get some dark blotches in the desert, and if you're very lucky, you'll get a white smudge top and bottom, which is your polar ice caps. So Mars, just at our level, don't even bother.
Assuming there's no dust storms.
And the last couple of years have been very bad dust storms. So if you look at Mars through the telescope, all you see is a red disk because the dust storms have taken out most of the details. So at our level, just put a line through Mars. Don't even bother. Okay. To get good photos requires a lot of magnification. So large aperture, long focal length telescopes work best. So typically we use a Schmidt-Cassegrain telescope. 8 inches and upwards are very good. Or long focus reflectors. If you've got a 150 millimeter long focus refractor, or reflectors, so a Newtonian, long focus Newtonian works very well, or a large refractor can also work very well. But most of the top guys use big Schmidt-Cassegrain telescopes, and they do it for a good reason. It's just the easiest thing to use to get decent planetary photographs. Okay, long focus Newtonian could give you very good results. All right. Try and shoot while the planet is high overhead. We are lucky here. The planets do come high overhead. In the UK, where clear nights are few and the planets are fairly low, the guys are shooting quite low to the horizon, and you get a gadget that you can put on your telescope. It's got little correcting prisms, and it corrects the refraction artifacts that you get from shooting close to the horizon. You get a purple stripe on the one side and you get a red stripe on the other side. And so you get this little prism that you set up, and we're lucky we don't need that. We wait until the planet is at least 30 or 40 degrees above the horizon, and then all that nonsense is taken care of and we can just shoot. So I haven't even really mentioned that here. Okay, shoot when the thing's up overhead, 40 degrees above the horizon or higher. Then you're shooting through less air, and your chances of getting good photographs are good. We would typically use either a Barlow lens or eyepiece projection, and I'll explain both of those in the next slide. So although I've got an 8-inch Cassegrain or an 11-inch Cassegrain or a 14-inch Cassegrain, I still need more magnification. So I've got a 2,000 millimeter focal length. I want more. I want 4,000. I want more to get that planet to a reasonably big size in my telescope. Okay. Again, single shot, unlikely to produce a decent result, and we use lucky imaging, which I've mentioned before. Generally with planets, we take videos. And the planetary cameras you put on there, and I've got a little planetary camera that I've played with, and I bought it as a guide camera, but it also works as a planetary camera. And this thing is insane. You put it up there, and it literally shoots 80 frames per second.
Jeez.
And on Jupiter, you can only shoot 5 minutes because Jupiter is turning very fast. And if you shoot more than 5 minutes, you get movement in the thing, and the stacking programs battle to stack it back properly. So Jupiter, you've got 4 or 5 minutes that you can shoot, and then that's it. Don't try longer. Then stop, start a new series of photos, because your stacking software is going to battle with it. And so you can imagine 80 frames per second over 5 minutes is a lot of frames. But what we do with that is only a little 2 megapixel camera, and we can actually set the software so we cut most of that 2 megapixel out, and we just frame that piece of planet that we want, and we reduce the file size dramatically, and we shoot AVI. It's called AVI format. And then you put that into AutoStack it or Registax or both, and it does your shooting for you. So we can't use planetary cameras for the competition. Canon, you can take video. Nikon, you can take video. Fujifilm, you can't, because it puts the video, it messes with the video. And it's a dirty format. It works fine, the pictures look nice, but when you put it into Registack or AutoStack it, it says, icon, not going to happen. All right, but you can with Canon and Nikon, you can shoot video. Try and shoot in AVI format. Okay, and so you can shoot 5 minutes of video. You're allowed to use a DSLR. You're allowed to use the mirrors. And then stacking, generally a program called AutoStack it is a bit better for stacking than Registax. So I like to stack in AutoStack it and then push it into Registax to do the wavelet sharpening. So the best results, the playing around that I've done, and I'm not a serious planetary photographer, it's not what I do, but I fiddled with it a bit, and I found the best one is shoot your video, put it into stack it in stack it. It's got very good stacking algorithms. Take the file that comes out, push it into Registax, go and fiddle with it to get it nice and sharp. And you can get quite decent results with that. Not terribly sophisticated. If you can't shoot video, if you've got a Fujifilm and you cooked, set up the intervalometer and again, Jupiter's bright. Okay, so set it up and take photos every second and just shoot for 5 minutes. You'll have huge files because you can't cut to a little piece in the middle, but it'll work. You put it into Registax, stack it, have a try, have a go at it. Okay, again, try and get your exposures a little bit on the dark side. The stacking program and the wavelet program works better with a slightly darker image. Once you've got the final image, you pull it into Photoshop and you play with it. You can lighten it up, you can increase your contrast, do what you want. Okay. Saturn, same rules. Same thing applies for Saturn. At the moment, the rings are almost edge-on. But, yeah, and it's small. It really is small. So you need more magnification. And it's more difficult to get a good photo of Saturn than it is to get a good photo of Jupiter. And Jupiter, you can actually do quite nice photos where you don't have insane magnification. You have Jupiter and the 4 Galilean moons. Makes a beautiful photograph, yeah. And you don't need to throw heavy horsepower at it. So a fairly small Maxitov would work well, yeah. So if you don't have that big firepower, you've got a smaller telescope. Jupiter with the 4 Galilean moons, really nice. And again, there's programs you can go and look on the internet. And there's a couple of sites that show you every evening where the Galilean moons are going to be at any time. So you can go and look up there and say, oh, 9 o'clock Friday night, there's a really nice alignment of moons. And if the cloud gods are with you, you can go out and shoot it. All right, so...
Would a DOB also work?
Yes, a DOB will work because you're taking very short exposures, and as long as there's not too much movement, the stacking program will put them together. Yeah. So you can certainly try a DOB. All right. If you're going to try this with a cell phone, and you can try it with a cell phone, for heaven's sakes, go and get one of those McGafties that fits to the eyepiece and holds your cell phone still. Be it the moon, be it the planets, go and buy one of those little clamps that clamps onto the telescope, onto the eyepiece, and holds your cell phone in the correct position. And then you can use the cell phone. It's got a lovely, the new cell phones have got very nice cameras in them.
Amazing.
They're amazing cameras, yeah.
Better than my Canon.
Just keep it still. Okay, so now we talked about Barlow's and we talked about eyepiece projection. We're speaking in tongues, sorry. So we have either prime focus photography or we have eyepiece projection. So prime focus photography requires a T adapter, which clicks into your camera. So it's an adapter that adapts whatever your bayonet lens mount is to a standard 42 millimeter T thread. And then you can screw all sorts of stuff into that T thread. Okay. So now, if you look at the bottom photograph there, you will see where the red ring, just other side the red ring, you will see the T adapter, which you can see on the lower left there. That's called a T adapter, and that's a Canon one. It'll bayonet into your Canon lens. And then onto that, you screw a 1 1/4 adapter, which you can see just to the left of that. That's Celestron one. And then you can slip that into the eyepiece socket of your telescope. You now have prime focus. Okay? But when we shoot, if you look at the left-hand photograph, you'll see that we've put in the red circle, we've slipped a Barlow in between. And a Barlow just magnifies 2 times or 3 times or 5 times of your sort of common Barlow magnification. So 2, 2.5 is generally what the planetary guys use. So 2, 2.5 or 3. More powerful than that depends on your scope. Okay? And again, these T adapters and T rings are quite cheap. You can actually, Celestron, sell a Barlow with a 42mm ring on the outside that you can just screw your T ring to. So, and if you're looking for this stuff, the GNL agencies are the local agents. Their online outlet is called digitechplus.coza. So if you go to digitechplus.coza, you can buy directly from the Celestron importers and buy it online.
Amazon also has these.
Amazon has those. Telescopium sells the SV Boney stuff locally. So telescopium.coza, and their pricing is quite reasonable. So that's your minimum, is T adapter for a camera, a Barlow, and you slide it into your telescope. And that's prime focus. All right. Then you can get very good results if you look up at the top right there with eyepiece projection. And what you're doing there is you're screwing an eyepiece onto the front of your camera, and you're using the eyepiece instead of a Barlow to get additional magnification. There's a lot of setups. Some have a housing that you put a standard eyepiece inside, and that encapsulates your eyepiece, and you clip your camera on the outside. The Barda lenses are very nice. The Hyperion and Morpheus lenses from Barda. You take the rubber cup off. It's got a 43mm ring there. You buy a little 43 to 42 converter ring from them. You screw the 43mm ring onto the eyepiece. You screw the T adapter into the 42mm ring. You pop the eyepiece into your telescope. You're good to go. And you get very nice results with that. If you're doing that, I found on the 8-inch Cassegrain that somewhere around 12mm eyepiece gave really good results. So on the 8-inch at 12mm was quite a sweet spot.
Would projection photography be better quality result than a prime focus?
I don't know.
Depends on your skill, I think.
I haven't done enough of both to be able to give you a definite opinion.
Because I can do prime at the moment, but I can't put an eyepiece in,
Yeah, you
or
see,
a Barlow in there.
I used the Barda Zoom, which has the same thing. You pop the eye cup off, you put the Barda Zoom, you can hook up like that Morpheus lens there, and the Barda Zoom's nice because you can zoom in and out and choose a sweet spot. That's why I'm saying I found 12mm to be quite a sweet spot. So you've got to have a look. Not all eyepieces have it. The Barda Hyperion and the Barda Morpheus have that feature on them. So they're very nice for that.
See, I can't even put a Barlow in my train. I can only fit camera straight into
No, you can
screen.
put a Barlow in your train. For planetary, you can put a Barlow in the train. It'll work.
Okay.
You do lower left hand corner there. It'll work just fine. Go try it. But you need the T adapter.
Yeah, that I've got.
Yeah, so try it. So you need the T adapter with the 1 1/4 neck, which are the two pieces on the right there. Telescopium sells an all-in-one, so it's got, yeah. You will need a T adapter. You will need that T to 1 1/4. You put the 1 1/4 into the back of the Barlow, which is basically accepts an eyepiece. Instead of an eyepiece, you put the nose piece in. You put the Barlow into your scope, and I promise you it'll work just fine. Go try it. Yeah, you've got a 5-inch Maxitov, 6-inch Maxitov.
Yes.
Yeah, and that should work very nicely. You should get good results with that. Go try. Worth a try. Okay. Any questions?
Do you have to also consider weight, like if you start adding? Because I do find on the smaller scopes it starts bending.
Well, you do, and on your setup, you always need to try and balance your telescope and camera rig so that you're not front heavy or back heavy. Good question. Again, if you're doing planetary photography for that 5 minutes, it helps a whole lot if you're on a tracking mount. Now, it doesn't have to be a polar mount, because the stacking software will derotate your photos for you. So an alt-azimuth mount will work just fine for planetary and for lunar. Your auto-stack it will derotate your photos for you. For deep sky, of course, you have to go.
I think the meeting's been disconnected, so people are complaining.
Oh, goodness,
they're not,
sorry. All right, let's just pause.
sure. Oh,
No, we're there.
we're there.
Can everybody still hear us? Are we still up?
Can hear you again now.
Hello. Okay, okay. I'm
Alright.
happy to see you again.
I hope you didn't miss much.
About 8 minutes.
8 minutes, all right. Shall I go back over the prime focus and eyepiece projection briefly?
Yeah, you were talking about shooting raw, and that's about when it stopped, yeah.
Oh, goodness.
Oh, goodness.
All right.
Wow.
Did you get the moon and the planets?
Yeah, you started on that.
All right. All right.
Yeah.
So really we were talking planetary. Let's just go back one. Did you get that piece?
Can't see.
Yeah.
You just started planetary. You said that the Mars was very difficult and there's a lot of dust storms.
All
and
right.
That's it, as
All
far as you
right.
got.
Let me go back over this very quickly then. All right. So Jupiter, easiest to photograph. Saturn, small. Mars, right off. You need a lot of magnification. So large aperture, long focal length, and we typically use long focus
I'm seeing
telescopes
your
like
video, but
Schmidt-Cassegrains.
not your presentation.
Hmm?
I'm seeing your video, but not the presentation.
Oh, did it stop sharing?
Oh,
Yeah,
okay.
because it was disconnected.
Okay.
We are videoing this. We do have a camera recording here, so.
Yeah, I'm saying I can see John,
Yeah.
but
It's,
not the
Yeah, we're
presentation.
about to pop
Yeah.
it back up. So.
yeah.
There we go. There we go.
There we go.
All right.
But yeah, we are videoing this, so we'll
Alright.
send it to you guys
Good.
afterwards.
Sorry about that.
Thanks for videoing.
All right. So we need long focus telescopes, and the larger the telescope, the better the results usually. Remember, your resolution is limited by the aperture of your telescope. So the bigger the telescope, the more detail it will pick up. And the pros who do this really well use these 14-inch Cassegrains mostly, this, or even 16 or 18-inch Cassegrains. The guys go quite crazy with this. Try and shoot when the planet is high overhead, 40 degrees above the horizon or better. And we usually have to use, or almost always have to use, either a Barlow lens or eyepiece projection to increase magnification, and we'll have a quick look at that in the next slide. And we use lucky imaging. So if you've got a Canon or Nikon DSLR, you can shoot video in an AVI format, and that'll work nicely in either AutoStack or Registax. If you shoot Fujifilm like I do, don't bother. The video, they do something funny with the video, and AutoStack it just gives you a middle finger when you try and process it. So I've had some success putting up the intervalometer and just shooting a whole lot of single exposures and then putting them in TIFF format and pushing them into AutoStack it. But then you're using a load of hard disk space to do that. All right. So you can shoot AVI with your DSLR, Canon or Nikon. Sony, I don't know. I'm sure that that's probably possible with a Sony as well. And AutoStack it tends to stack better than Registax. So the playing around I've done, I find AutoStack it, stack up in AutoStack it, and then push it into Registax to do the wavelet sharpening on the resulting photos. And you can get quite good results. So we're shooting either prime focus or eyepiece projection. So for prime focus, we will require a T adapter, far right bottom of the screen there. And we will need a T adapter to eyepiece adapter. That's Celestron one just to the left of it. You screw that T ring into the back of the Celestron or any other brand of T to eyepiece adapter, and we then slide that into the back of the telescope. And for planetary, if you look on the bottom left, we put a Barlow in between. So it's T adapter, 1 1/4 adapter onto the T adapter, Barlow into the back of the telescope. And we usually want that distance from the Barlow to our film plane to be 55 millimeters for DSLRs. So if you buy those two adapters, they will give you the correct backspacing to give you good results. Alternatively, we use eyepiece projection, where you actually screw an eyepiece into the front of the camera instead of a Barlow, and then slip that into the telescope to get more magnification. And the only eyepieces I'm aware of where that can be easily done are the Baader, Hyperion, or Morpheus eyepieces. You take the rubber eye cup off, it's got an M43 thread at the back. You buy a little Baader M43 to M42 ring. You screw that onto the eyepiece, you screw that T adapter that you can see bottom right into the back of that, and you pop that into your camera, and you are good to go. You slide that into the back of the telescope, and you don't need a lens. You just use the eyepiece, and you're good to go. All right. All right. So I think that's the point we were at. All right. So let's talk briefly about meteors. So the moon and the planets you can do here in Joburg, no problem. You'll get good shots. They'll come right. Everything else we're going to talk about now, we're talking dark sky. Don't even bother in Joburg's light pollution. You need to go to a dark sky site to have any chance of success with meteors or landscape or whatever. So, good excuse to go on a nice camping or other holiday with your family. All right. So, meteors. Sturdy tripod, essential. You've got to keep everything still. Use a wide-angle lens. Suggestion 14 to 20 millimeters on a full-frame camera, 10 to 14 millimeters on APS-C. You want to catch a lot of sky. DSLR mirrorless camera with manual controls. So again, we shoot full manual if we possibly can. Shoot in RAW. Go through that focus scenario and make sure you've got manual focus. But here we're not going to stop down. Here we're going to use the maximum aperture. So one time we use maximum aperture because some of the meteors are quite dim. Use your widest aperture. Go to ISO 1600 or 3200. Okay, and you apply the 600 rule for exposure to avoid star trailing. When you go on the internet and look, you will see people talk about the 500 rule. 500 rule worked well with film. It doesn't work well with digital cameras. It's not forgiving enough. And on the modern digital cameras with the high megapixel sensors, even the 600 rule doesn't work very well. And I'll expand on that a little bit. Or there's a nice little freebie that you can put on your cell phone called Photo Pills. And they've got a spot stars function there. And we'll look at the spot stars. So you download Photo Pills. It's got a lot of nice functions. Shows you where the moon is on any day. It gives you a lot of very useful information for astrophotography. And it's free. So again, a very nice little app that you can download. So with the 600 rule, we take 600 and we divide by the 35 millimeter equivalent focal length. And that gives us an exposure time in seconds, where we should see barely noticeable star trailing, or none at all, okay, depending on your sensor, etc. So if we take, I think most of us shoot APS-C, if we take a 10 millimeter lens on an APS-C sensor, that's equivalent to 15 millimeter on a 35 millimeter full frame. So we take 600 divided by 15 gives an exposure time of 40 seconds. So the 600 rule tells us with a 10 millimeter lens on the camera, we can shoot for 40 seconds and we won't see star trailing. That is wildly optimistic, unfortunately. Okay. That's why I'm saying the 500 and 600 rule don't work very well on. Now we go to Photo Pills, spot stars, and we put in there, I want 10 millimeter lens. I've got at f4, an APS-C sensor, and I want an accurate. The accurate setting says you will not get star trailing. It's conservative. and I get an exposure time of 17 seconds. So as a rule of thumb, if you want good results, apply the 600 rule and then halve the exposure time. And you should get pretty decent results. And yes, we're shooting meteors, so we have the shutter open, but the problem is that if we have the shutter open for too long, the background stars are going to trail. So again, it's a crapshoot. You've got to take a hell of a lot of exposures
These meteors just happen.
and see what happens. So you aim the camera at a piece of sky about 40 to 60 degrees away from the radiant, which is the point from which the meteors appear to originate, and you put on an intervalometer, built-in or external, and you just take continuous shots. Let's say I've got my 10mm lens at f4 on my camera, 17 seconds, stop a second, 17 seconds, stop a second, 17 seconds, stop a second. And I just shoot, and then you go through the photos afterwards, and anything that you've captured with a meteor, you can put them into, so they should be perfectly all the same, bar the meteors, etc. And you should then be able to put them into Photoshop, and you should be able to stack them in Photoshop. I'm just trying to think what the blending mode is. I think it's lighten. Will, I think, give you, pull through just the meteor streaks for you. There is one. I've not done meteors at all. Okay. As a bonus, try and include a landscape in the foreground to add scale and interest. And we're going to talk about including foregrounds in the next section. Photographing meteors requires a dark sky, Bortle 1 or Bortle 2. Okay. With the little planetary cameras now, they give you a little lens, and you can mount that camera on a tripod, and it picks up just about the whole sky. And ASI have a little piece of software that you put on there, and the thing sits and waits, and the moment it sees a meteor, it shoots a photo. So every time a meteor appears, it'll shoot a photo, and obviously you can then track the time that those photos appeared, and you can go and stack them afterwards and do all sorts of nice stuff with it. But we're not allowed to use astro cameras. That's not an option here. So if you're not... All right. All right. And then starscapes with the terrestrial foreground. So again, a very interesting area, and some guys take marvelous photographs. They really do. They do some absolutely stunning stuff. And again, I've played with it a little bit, but I've not got results good enough that I want to go brag about them. So starscapes with the terrestrial foreground. Again, dark sky. You have to have dark sky. So find a location with dark skies and an interesting foreground. If you want to include the Milky Way, make sure it will appear above your chosen foreground. Use Stellarium and a compass. Go check your alignment, or use one of these little cell phone apps and make sure that the Milky Way is going to align with your foreground and is going to appear above your foreground. Okay. It's important to do that in daylight, and I'll explain why shortly. Use a sturdy tripod or a tracking mount. Okay. Fast wide-angle lens, same as meteors. DSLR or mirrorless camera with manual. We shoot everything manual. Use your widest aperture. Go for ISO 1600 or 3200. Apply the 600 rule for exposure. Does this sound familiar? Same as meteors. Okay. Shoot in RAW and focus manually. So nothing too new there. That's your basic setup. Recommend you set up before dark and you take your foreground photos in blue light. Now what's blue light? It's when the sun has gone fully down, the sunset color has cleared from the sky, and you get that blue light comes in just before it starts to get dark. Take a series of foreground shots there because you've got enough light to be able to take foreground and still have some detail in it. And you've got that nice dark blue sky above it, which you can blend in with your exposures later, or you can cut your exposures in afterwards. Okay. And wait don't move the camera, wait until dark, and then take the sky shots. All right. So there's a couple of strategies for taking the sky shots. You can apply the 600 rule, take a single sky shot, cut it into your foreground. Or you can take a series of fairly short sky shots, and you could then try and align them in Photoshop, stack them in Photoshop, and then cut it into your foreground. Or if you've got a tracking mount, what you can do is, without moving the camera, just move it up a little bit to bring the foreground right down into the bottom of your frame. Because with a tracking mount, your foreground is going to blur and it's going to turn. So you want to get that out of your photo. So go above. You've still got the same Milky Way. You've still got the same piece of sky. We're jipping a little bit now. Shoot your 20 or 30 or 100 shots. Go put them into your processing software. Process the sky as you would with deep sky. And then cut it back into your foreground in Photoshop. So you lower it again, you lose the bottom of that frame. You've got a full sky that you can cut in on your foreground, and you've lost nothing basically. Okay. So if you want to stack the sky shots, use an equatorial mount. Okay, so that's what we're saying. Lift the camera, foreground goes, foreground will blur, and it'll give you space to work for it. So after dark, start tracking and take the sky shots. Again, shoot RAW or shoot TIFF if you can. And from RAW, convert to TIFF. And now you use a software that we would use for deep sky. So Cyril is really very nice software, very easy to use. It gives very good results, and it's free. Yippee, which is always nice. So you go and you stack your photographs in Cyril, and again, read up on it. There's some very nice tutorials on YouTube. Some of the guys talk crap, but there are some very good tutorials on YouTube, and it's quite easy to use. And stretch your sky to get your Milky Way the way you want it and everything. And once you've got that result that you want, bring it in with Photoshop and cut it into your foreground. Okay. You can also use Deep Sky Stacker. That also works well. It's older software, not quite as easy to use as Cyril and the more modern softwares, but Deep Sky Stacker works fine. A lot of people have been using it for years and like it and use it. Any questions at this stage? Some guys set up, and then after dark, you'll see they've got those rock faces and stuff. So they do a long 5-minute exposure, and they go with torches and stuff, and they light up the rocks. Yeah, you can get good results there, but it's a bit of a hit and miss. You've got to look at what you've got and say, well, put too much light there, not enough light there, go back in. So that is a method that some people use. They go and they actually illuminate parts of the foreground after dark. Can work, but it's kind of easier to shoot your foreground in blue light and then cut the background in later. All right. And then remember, we're shooting up with a wide-angle lens. So your foreground, you might want, once you've got everything cut in Photoshop, you've got the final photograph, you might want to adjust your perspective. And I hope I'm not going to upset anybody here, but in the winter competition, Guy took a very nice star trail photograph with a house in the foreground up into the sky. It was a very nice photograph, but the house was falling backwards. All your verticals were converging. The house was falling backwards. 5 minutes work in Photoshop adjusting the perspective would have picked the house up, made all your verticals nice and straight. You just stretch your sky up again, and it just looks so much nicer for 5 minutes work in Photoshop. So if you've got buildings and stuff or telephone poles or stuff in your photo, you may have to go and adjust your perspective in Photoshop.
Etsua has a question.
Okay, Etsua?
I'd like to ask one thing. I was used to take a stereo foreground picture with a film camera, SLR camera, reflex lens camera. In case of that, the lens shading is a big matter. So I used to reduce the aperture to avoid the four corner getting darker than the other part. So I used to reduce the aperture. But in case of digital camera, don't we need to reduce the aperture?
With a cell phone camera, I think you take what you take. I don't think you can do that. And that is still very relevant nowadays. A lot of lenses go soft in the corners, and if you want the corners to be nice and sharp, you have to stop down. There are some lenses that do give good results in the corners and don't have chromatic aberration on the edges. And those are very nice lenses. And if you are quite serious about this, you go and buy one of those lenses. Now, there are various makers, and some of the lenses in the ranges, Canon makes some lenses that are good with that respect. Fujifilm make lenses that are good. Nikon make lenses that are good. If you're serious about this, what gets a very good write-up and are highly considered are the Samyang or Rokinon manual focus lenses. They're relatively cheap. The wide angles have very good glass and they get very good press. I bought a 12mm Samyang f2 lens exactly for this, and it's super. It's an f2 lens. I stop it down to f2.8 and it gives me very nice results. The guys who shoot deep sky, the 135mm f2 Samyang has got a very, very, very good reputation. It's considered better than the Canon f2 135mm, which is a very, very good lens.
But when you take the starry sky foreground, do you use full aperture? I mean, you don't need to reduce the aperture.
No, what you can often do if you're shooting blue light is you shoot a normal landscape photograph. So you can stop down so that you get a big depth of field. So you got from the foreground back to the horizon, so you can stop right down to f8 or somewhere around there and make sure you've got your foreground all nicely in focus. And then once it gets dark, refocus on the stars and shoot your stars in your sky. And so you've got that foreground that you shot in blue light where you could use a nice long exposure. You have no stars to blur. And so you've got your whole foreground nicely shot. And then you refocus and take the night sky shots.
To make to get a good star image in the corner of the field, I mean, and the center is good, but the other part, the corner, four corners getting worse when we open the aperture.
Yeah.
So we used to reduce the aperture to
Yes.
get the better image and equal image in the center or the edge of the field. So
We still do.
I'd like to know.
We still do. We still do.
Yeah. What's the best aperture?
The digital sensors are more sensitive than film to that, so we still do. We still do. There is some software that to some extent can fix bad corner stars, but that's not something I want to go in here. And the really, really good software is extremely expensive. So you are paying 300 euros for the base program and then another 100 euros for the software that fixes your bad corner stars. So you're paying 400 euros to get slightly better corner stars. You have to be very, very serious astrophotographer to lay out that kind of money. So we're not even looking at it here. Stop down one or two stops. But as I say, the Samyang lenses, some of the Samyang lenses are particularly good. You don't have to stop them down very much at all. The Canon L lenses are good. You'll get good corners with them. The Nikon gold ring lenses are good. You will get good corners with them. But always, if you stop down a bit, you will get better results. It doesn't matter, digital or film. If you stop down a bit, Etso, that's a very valid point. We still do it. It's still valid.
Okay. Thank you. Thank you very much.
Thanks, Etso.
Yeah.
Very good point.
Yeah.
All right, so we combine the foreground and the sky using image editing software, Photoshop, GIMP. Alternatively, you can do that nice foreground and then, without moving the camera, try capturing star trails. So you do your nice foreground in blue light, you leave the camera where it is, and you capture star trails. Digitals don't like shooting for 3 hours uninterrupted. The sensors get hot and it gets noisy and it is problematic. So we generally start, you can try a 30 or 90-minute exposure with the digital camera. I don't know if you're going to be happy or not with the results. Generally, we would shoot 1 or 2 minute exposures, give it a 10-second break, shoot another 2 minutes, give it a 10-second break. And so the break between exposures is short enough that you're not going to see any gaps in your star trailing. And you do that, 30 or 90 minutes is going to give you quite nice star trails. Aim the camera south if you want a circular pattern, so aim it towards the South Pole if you want to get those nice circular patterns in the sky. You're going to need, if you're going to shoot the 30 or 90 millimeter exposures, you're going to have to put it on the B setting and lock the shutter open with a cable release. And then unlock it after the 30 or 90 minute exposures. If you're shooting 2-minute exposures with short gaps, intervalometer will do that job for you. You set it up and you do that job. Okay. We are trying to minimize sensor heat because sensor heat equals noise. With a dedicated Astro camera, we cool the sensor down to somewhere between -10 or -25 degrees C to keep the sensor cool to reduce noise. With the DSLR, you can't do that. If you've got a rear screen on your camera, switch it off. If you can fold the screen out, fold it out, because it will take insulation away from the back of the camera. And consider using a dummy battery, because your battery inside the camera will run quite hot. Mirrorless is terrible. They eat batteries, so you're going to have to try and change batteries every, 30, 60 minutes, because you're shooting 300 exposures, you're done. So consider using a dummy battery to minimize sensor heating and reducing noise. Now, what do I mean by a dummy battery? Again, go look at Amazon. It's a casing that's shaped like your battery. It's got electrical contacts like your battery, but it's got a cable on it. You take out your battery, you slide this thing in, you close your battery door, and then it normally has a little power supply, runs 220 to, in the case of Fujifilm, 8.4 volts. And so you power your camera off mains power. If you're running off a 12-volt battery, then you are going to have to go and buy what's called a DC buck, and you're going to have to set that up so that you go from 12 volts to 8.4 volts and you don't blow your camera electronics to pieces. Again, please don't do that unless you know what you're doing. But it's cheap and easy to do if you do know what you're doing. So dummy battery generates no extra heat in the camera, and it also helps to reduce sensor noise. And you don't have to worry about changing batteries periodically and shaking the camera and all of that good stuff. Okay, if you've got a 220 volt power supply, no problem at all, because it's got a little power supply that reduces it to your camera voltage. Again, they're not wildly expensive. So well worth looking at. And yeah, the way to get started is to quit talking and begin doing. Walt Disney. So you are not going to get good at it unless you go out there and you spend some time and some sweat and some naughty words. That's how you get better. You go out there and you battle and you get results, and you get out, and the next time you battle less, and the next time you battle less, and go and look at YouTubes, go and read up, work up your knowledge base. And so pick one of these and try and work at it, and you'll get good at it eventually. And there are no shortcuts. As I said, you're not going to walk out the door, point a cell phone at the camera and take a prize-winning photograph. You're going to have to put some sweat into it. And when you see these really nice photographs that get entered into the ASA photo competitions, the guys who enter the really good photos at the top, I can assure you, have put hours and days, not just to capture the photographs, but to do the post-processing. And they've put blood into these things. And that's why they get the good results. It's commitment and it takes effort. Okay. And good luck, have fun, and try and take a Saturn photograph like the Hubble does. Right.
Thanks, John.
Over to you, Alison.
Thank Thanks, John. That was an excellent talk.
Let me just hear. Are there any further questions?
Yeah, I'd like to make a few comments.
Sure.
For those who are trying to do long exposures with DSLR, you can remember the old hat trick that used to be used in the days of film camera, where you, in that case, they would use a hat. You can put a black card in front of the lens, open the shutter, and a second or two later move the obstruction out the way. And that's so that the system can settle down in terms of vibration.
Yeah, that'll work. And probably easier than, but if you're taking a series of photographs, your intervalometer generally triggers without shaking the camera.
Much longer, thicker chunk of atmosphere than if you're looking directly overhead. So you're going to get more turbulence, and that makes it more difficult. You asked about meat. They're extinct, but Lunt make a really nice solar telescope, unfortunately out of my price range. For eyepiece projection, you really need a good coupling to prevent flexure, and a lot of focuses are just not up to the task, right? Then as far as the wide field's concerned, the short focal lengths of wide-angle lenses distorts the foreground, and rectilinear features in the foreground, that's things that are square or angular with straight lines, are particularly obviously affected. So we covered a lot. It was an excellent talk. Thank you.
All right. Thank you, Chris. Yeah, an excellent lens, extremely, extremely sharp, but it's not rectilinear. If you can still get your hands on one, is the old Canon 15mm fisheye. So if you're doing, you can do a foreground with the rectilinear and then put the 15mm fisheye on and shoot sky up top, and then marry the two together. That is a brilliant lens. It's an f2.8 lens, and it's cracking sharp even at f2.8, but it's not rectilinear. All right. Thanks, guys. I hope you enjoyed it.